Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solutions for educational code forces round 137, which was rated for division 2. So in this video, we're going to discuss the first three problems. And before starting the video, I would like to thank you all for watching these videos. And if you find these videos helpful, then please do consider subscribing to this channel. And now let us quickly start with the first problem, that is password. So this particular problem says that Monocarp has forgotten the password to his mobile phone, and it has 4 digits from 0 to 9. So basically, the password is 4 digits, and it can be any digit from 0 to 9. And this says that the password has exactly 2 different digits, and each of those digits appeared exactly 2 times. So basically, like if the digits in the password are 2 and 4, so the password can be like this, the password can be like this, the password can be like this, and the password can be like this. So the password can be something like this, or a permutation of these numbers, right? So this is our question. Now the question, the second part of the question says that Monocarp remembers that there are some digits that were definitely not used in the password, and we have to calculate the number of ways in which the 4 digits password can be possible, providing verifying the above constraints, right? So for example, this is the first question, first test case, and it says that there were 8 digits that were definitely not in the answer. So these are the 8 digits that were not included in my password. Now if from the total of 10 digits I remove 8 of them, so there will be only 2 digits left. And you will observe that no matter what these digits were, we are only concerned about the number of digits left in the answer, because we just have to print the count of the possible passwords, not the passwords themselves, right? So we are just concerned about the number of digits that are remaining. So we have 2 digits remaining, right? So obviously I can choose both of them and form a permutation from both of them. So let me take the second example. Now it is better to understand. For example, I have an option of 10 digits. So I'm basically discussing the permutation way of doing this question, and there might exist some simpler way. But if you understand this method, then it will definitely help you in the future, because these permutations questions are very important. Like in most of the CP rounds, they're very frequent. So I'm going to discuss the permutation method of doing this particular question. So there's this 4, 5, 6, 7, 8, 9. So if I remove this 8, then I'm left with 9 choices, and I have to choose exactly 2 of them, right? So if I have to choose 2 integers from a group of 9, then my NC2 would be equal to 36. So I have 36 ways of choosing those integers, right? Now if I have got those 36 digits, there might be some ways in which I have to arrange them, right? Because all of the arrangements would be different. So as for the arrangements, you will observe that we have 4 digits. So the number of arrangements will be 4 factorial, but 2 of them are repeated. The first 2 are repeated and the second 2 are repeated. So we divide both of them. So this is basically equals to 3 factorial, or 3 into 2 into 1, which is equals to 6, right? Because this 2 into 2 will cancel out the 4, right? So we have to multiply this value with 6, right? So if I multiply it with 6, I get the result 216, and this would be my final answer. So basically I just have to check how many ways I have of choosing 2 digits out of the remaining digits, right? And if I have chosen them, in what ways I can arrange them. So for finding the arrangement, you only have 6 permutation always, because the pattern is always the same, that you have 4 digits and 2 of them are repeated twice, right? So let us have a look at the code now. So here what I have done, I have created a array fact. So this will basically store my value of factorials. So I just pre-compute this particular array. I set fact of 0 is equals to fact of 1 is equals to 1, and for all the other remaining values, I calculate factorial of I is equals to factorial of I minus 1 into I, right? So this way I can basically calculate all the factorials, right? Now I've taken the input in a vector v, but as I've already told, I'm not concerned about those values specifically. I'm just concerned about how many values are remaining. So I calculate the number of remaining values as 10 minus n. So like in this way, I can just basically calculate the NCR. So NCR is basically equals to, so NCR is n factorial divided by n minus r factorial into r factorial, right? So in this case r is 2, so I am storing this particular part in y and I'm storing this particular part in x. So I'm calculating y as r factorial into n minus r factorial, and I'm calculating x as r factorial, right? So I can find my answer as x by y, and I can just finally multiply it by 6 for the number of permutations, right? And then I can finally output my answer. So this would be the solution for the first question. Now moving on to the second question for today's contest, which is permutation value. So this particular question says that we have been given an integer n, and we have to like construct a permutation of those n integers such that the value is minimum. Value is minimum. So how do they define value? For example, if we consider this particular subsegment, like this particular permutation of 4 integers, then its value is 3. So how it becomes 3? It becomes 3 because it has 3 subsegments which are also permutations. So if we consider the first subsegment like this, so this is also a permutation of n is equals to 2, right? If I consider the whole one, then it is a permutation of n is equals to 4. If I consider this particular element, then it is a permutation of n is equals to 1. So this is how they have defined the value. So for example, if I have something like 1, 2, 3, 4 and 8, 7, 6, 5, right? So this is like a size, this is a permutation of size 8, right? So if I choose this particular subsegment, then this is a permutation of size 4, right? If I choose this particular subsegment, this is a permutation of size 3. If I choose this particular subsegment, this is a permutation of size 2. So the number of such permutations, the number of such subsegments in any permutation is called its value, and we have to construct a permutation of size n with minimum value, right? So there will be many possibilities, or there will be many ways to solve this particular question, but one of the ways is you can just take the, for example, if n is equals to 6, we will consider two cases, n is equals to 6 and n is equals to 7. So if I consider n is equals to 6, I'll have 6 integers, right? Then I can choose the first one and the last one, right? So in this way, again I can choose the second from the start and the second from the last. So I have 2 and 5, then 3 and 4. So if I form a permutation like this, you will see that the only two the only two subsegments which are permutations are one itself, right, and the whole array itself. So these are the only two subsegments present in this particular permutation, which are also a permutation, right? So the value for this is 2, and 2 is the minimum value that we can have, right? So this is a way of doing this. Similarly, for n is equals to 7, if I have 5, 4, 5, 6 and 7, I can take from the first and then from the last, then from the first, then from the last, then from the first, then from the last, and when I have reached the middle element, I can just print the middle element. So similarly, for this particular permutation, the value of this permutation would be equal to 2, and this is the minimum value that we can have for any permutation, right? So you can just use this method and get your answer. So what I have essentially done is I have created an integer n and I have taken input, and I just run a loop from 1 to less than n by 2, and I increment I by 1 every time. Now I just print I and n minus I plus 1, right? And if the value of n is odd, then I just print n plus 1 by 2. So this is basically the middle element which I have, right? So this is the middle element. So in case n, the value of n was odd, I just print the middle element at the end, and after it I just print a new line. So this would be my solution for the second question. Now moving on to the third question for today's contest, which is save the magazines. So this particular question says that we have been given some boxes, right? These are the boxes and these are the values in it, right? So basically these are the number of magazines in each of the box, and 0 denotes that that particular box has not been covered in a lid, and 1 denotes that that particular box has been covered in a lid, right? So it is raining and we want to like maximize the value of those boxes which are covered, right? So let me just define first what a value is, and then I'll define the operations. What operations does the question says are possible, right? So if I have this, so if you observe that the second, third and fourth boxes are covered, so the total value is 5 plus 8 plus 9. So this would be equal to 22, right? So the current value is 22, and we just have to maximize this particular value in our answer, right? So we can perform a series of steps after which we can maximize this, right? And I will explain what are those steps. As mentioned in the question, what you can do is, for example, if the left lid isn't covered and the right lid is covered, you can just move this lid from here to here, and it will be something like this, right? So the left box will be covered and the right box will be left uncovered. There is one more constraint. You can move each lid at most once. So if it is something like this, you can make it like this, but not like this. So from this particular state, this is acceptable, but this is not acceptable, right? So this is the constraint on moving the lids, and the lids can only move to the left, and you can just move them by one space. And if a lid is moved once, you cannot move it again. So these are the constraints on the question. Now this particular question has a pretty simple observation that for example, if you have this lid uncovered and then you have a series of lids covered, right, then you can make this particular box covered, and there are like essentially some number of ways in which you can make this box covered, right? So obviously if you want to make this covered, one of these boxes will have to be uncovered, right? And you have the like liberty to choose any one of those boxes. How? I'll show you. If you choose this particular box, it is very obvious that you can move the lid to the left and it will be left like this, right? But if you decide that I don't want to leave this particular box uncovered, I want to cover this box, then you can further move this lid to here, and then this particular box will be uncovered, right? Similarly, if you move this particular lid to here, then this will be covered and this will be uncovered. And at the last step, what you can do is all of these will be covered and this will be left uncovered. So you will basically observe, if you have a 0 and then you have a series of ones, right? You can choose any one of those and leave it uncovered. This will all be covered, right? And rest of them would be covered, right? Then you can essentially jump to this position, and for this 0 you can check whether I can choose some number of some other lid which I can then uncover and then cover this lid. So again, one more thing, if you have a 0 and you have some zeros after it, then you can never cover this particular 0. You must have a 0 and then you must have some number of ones, then you have the liberty to choose any one of them, right, and make it uncovered, right? If you have only one number of ones after it, for example, if it is like this, then you can choose only this one. If you have some number of ones contiguously, right, if you have some number of ones contiguously, then you can choose any one of them. But if I have a 0 here and then I have some number of ones, you cannot like make this particular lid covered by choosing one of these, right? So basically, if you have a 0 and then you have some number of ones after it, you can choose any one of them, make it uncovered and make this one covered, right? So for every 0 you encounter, if there are some number of ones after it, then you can choose one of them. Now the second task for us to find out is how should we choose them, right? For example, if this was the test case, then I have 10 here and I have 5, 8 and 9. So this is the case I was talking about. We have 1 0 and some number of ones after it, right? So what I can do basically is I can choose this particular 0 and I can take any one of those, like any one of those numbers, make it uncover and use it to cover this particular number, right? But which one of these should I actually choose? So the answer to it is very simple. I would always choose the particular index which has the minimum value. So in this case, it has the 5 has the minimum value. So I would definitely choose this one. In the next step, I check whether the minimum among these is actually smaller than this particular value. So if this value, the first value was 3 and this was 5, 8, 9, and if I choose the minimum among these, then 5 is still greater than 3, right? So replacing it wouldn't make any sense. So the first value should be greater or equal to than the minimum of these. So in this case it is 5 and in this case it is the first value was 10. So definitely 10 is greater. Then I can exchange those lids, right? But for example, let us assume it was something like this, right? It was in this particular order, or let me take just 5 in the middle, 5 and 8. right? In this particular case, I would have still done the same. I would have still chosen 5 and shift these two lids to the left one time. So this will go here and this would go here. And then the resulting would be 10, 9, 5, 8, 8, 1, 1, 0, 1. Right? After I do this particular operation, then I will jump to the next position. The next position means the position at which I have a 0 now. Right? So this is how we will approach the solution, and let me just show you the code now. So this is the solution that I formed. I take an integer n and then like a string s. So I just add a random character to the front of s because I just wanted to make all of it one based indexing. So it's your own personal preference. You can just do it with zero based indexing as well. So I just create a vector of size n plus 1, which is value which will be storing the values at each particular index. Now I just run a loop and I input the value. So if s of I is equals to 1, I increment my answer with value of I. So initially I am just assuming that this would be my best answer, right? Now what I do is I just find my first 0 in the whole string s, right? As soon as I hit a 1, I just increment the index and I keep doing this. And if I hit a 0, I just break out of it. Right. So this I'm doing this particular loop to find the first 0 or the occurrence of the first 0 in my string S. Now once I have found it, I can just run a loop till less than n plus 1. And I can just check like I'm storing next will be storing index plus 1. So it is just the next index to the current index. So if next is greater than or equal to n plus 1. So if it is out of bounds, or s of next is again a 0. So if I have two zeros like consecutively, then I can just increment my index and continue, because I cannot, like, if I have two zeros like this, then I cannot cover this particular magazine box in any way, because I still have a 0 to the right of it. So it's better to just move on, right? So that's what I do here. I just increment my index and continue. Now I initialize my remove variable and my dx variable. So dx will be storing the index of the minimum value among the subsegment having all ones, and remove will be storing the actual value which I have to remove, right? So I just loop through it, and while in next is less than n plus 1 and s of next is equals to 1. So while I'm having a contiguous subsegment of ones, I can just loop through it, and if I check if value of next is less than remove, I update the value of remove. Otherwise, I just I update the value of remove as well as I update the value of the index at which the minimum value is present. Now I just increment my next index after I have completed all of these loops. So if the value of remove is smaller than the value of index, so index was the position at which 0 was present. So I'll just remove my answer, remove the value removed from my answer, and I'll just increment this particular value in my answer. And I'll update my index as dx, like as for going to the position of the next 0. And then at the end, I'll print my answer. So this was the solution for the third question. And I hope you guys were able to understand the solution. So till the next video drops, stay safe, keep coding. Bye bye.